Welcome to Precalculus Concepts 27E, underneath graphs of sine and cosine. We are going to talk about more in depth the period and the amplitude for the cosine curve. There's 4 boxes. This is going to look very similar to what we did with our work in the sine, because it just so happens that the period for cosine and sine are the same, which of course is 2 pi. So what does it mean when I'm talking about period? Well, what I mean is I'm talking about the distance in radians that it would take to complete one full cycle. So if we look at the basic graph, and I start here at 0, 1, and I consider that like my high point, and this of course my middle point, my low point, back to my middle point, and then finally back to my high point. Well, how long is this? How many radians does this take? This takes a length of sort of 2 pi radians, okay? So 2 pi radians. So therefore, the period for the cosine curve is 2 pi. And that's basically what we need to know for our first box here. The amplitude for box 2, for cosine curve, is the exact same as it is for the sine curve. Again, let me refresh your memory in saying that the amplitude is the distance from the midline of the graph, which I'm drawing for you right now in black dotted lines, all the way to the highest point or the lowest point, all right? So in that case, this is a distance of 1 unit. So when we talk about the amplitude, we're talking about the absolute value of the distance between the midline and the highest point or the lowest point. So in this case, the amplitude is absolute value of 1 or just 1 in this case. So we're going to use this in the next box. Okay, box 3 is an example, and this is an important example because I'm going to illustrate a couple of different points that we need to understand about period, and then the next one we'll do amplitude. So I am asking us to sort of consider what would be the period for this graph right here, this blue graph, the cosine of 2x. You probably notice that there's a 2 inside the parentheses, and we want to understand what that 2 does and how that 2 affects our graph. So let's consider our basic sketch in red here, the cosine curve. So remember I have a 0, 1, I have pi over 2, 0, I have pi negative 1, I have 3 pi over 2, 0, and then I have 2 pi. So if I consider tracing this out in red, like I'm doing right now, and I look at that period, that is the distance to complete that cycle, that would be a distance of 2 pi radians, and so that's something that we know or we have under our belts here. The blue graph, though, is the one that we're interested in. So if I consider my 5 points for the blue graph, I have a 0, 1. I have some point here, which is going to be the halfway distance between 0 and pi over 2. At pi over 2, I'm at negative 1. At this point, I'm halfway up again. And then over here, I have ended up back where I started. So if I trace this out in blue, like I'm doing right now, you have to ask yourself, well, what is that distance, right? Or how many radians is this? And this would be pi. So clearly, the period for this one is pi. Now, how do we calculate that? Well, like we did before, we take our original period, which is 2 pi, and we divide by whatever number is in between the trig function and the variable. So if I divide by 2, I cancel out, and notice I get a value of pi. That is represented in this part right here. That is what the pi means. Okay, that is our period. So then many students ask, well, what does the 2 mean? The 2 means that you would get 2 full cycles of cosine on a distance of 2 pi. This is in purple for you. So here's what I mean in purple. This is 1 full cycle of cosine, and then look, here's another full cycle of cosine. So I have 1 over here, 2 together. So that means this 2 means that I will have 2 full cycles of cosine on 2 pi radians. But the period itself is worth pi radians. Okay, box number 4 is an example. Let's determine the amplitude for the function y equals negative 4 cosine of x. Okay, so for comparison's sake, I have started off our graphing here with the basic cosine curve for x. So notice I have 0, 1, I have pi over 2, 0, I have pi negative 1, I have 3 pi over 2, 0, and then of course I have 2 pi. Now the regular amplitude, as we discussed before, was the distance between the midline and the highest point or the lowest point. So in this case, it's a value of 1. Now let's consider the blue graph here, you're probably noticing that there's a -4. Well, hopefully you notice that the negative out in front is going to give us a reflection over the x-axis, and the 4 is going to push the amplitude from a value of 1 to a value of 4. So what do I mean by that? Well, here we go. Again, the midline hasn't changed because I have not moved this graph up or down at all, but the distance from the midline to the highest point here, you'll notice, is a value of 4. Same thing from the midline all the way down to the lowest point. This is also a value of 4, or distance of 4. So the amplitude in this case is going to be the absolute value of -4, which is just 4 in this case. So that's all amplitude does, and it is characterized by the number out in front before the trig function itself.